Greetings and welcome, friends. Mr. Wada here. We're going over a couple problems. We were graphing quadratics in the form f of x equals ax squared plus bx plus c. And we learned a good little trick that the vertex, which we refer to as h comma k, that the h, we had a formula. You can find the x coordinate of the vertex by doing negative b over 2a. Or I guess mathematically, we typically would say the opposite of b. Because what if b was already negative? So that's how you can find the x-coordinate of the vertex. And the y-coordinate of the vertex you can then find by plugging that h into the function. So that was kind of like the core idea. Yesterday we talked about this idea of minimum and maximum values, which you can determine. Well, let's just do this problem. Here's 23. So to figure out a, b, and c, let's see. A is negative 4. Yeah, B is this 4 right here. I like it. So let's see. Tyler, based on the fact that A is negative, what direction do you think this opens, up or down? What are your thoughts? Well, it turns out if A is positive, it opens up. If it's negative, it opens down. All right, so no worries. And since it opens down, Kayla, do you anticipate that it'll have a minimum value or a maximum value? Imagine yeah, right? If it opens down, then it's going to be a hill, and it's going to have a maximum value. So we're looking for a maximum here. Right? So let's find the value of h. It turns out that the maximum value is going to end up being the k. Will be our max value. It'll be the y-coordinate of the vertex. So to find h, I'm going to have the opposite of 4 over 2 times negative 4. And h is going to equal negative 4 over negative 8. Ooh, oh dear. Positive a half. Yikes. That means I'm going to have to plug in a fraction here. Our fraction skills coming to the test. Here we go. So f of a half, I'll walk you through this, don't you fret, is equal to negative 4 times a half all squared plus 4 times a half minus 2. All right. This actually isn't that as bad as it could be. Squaring a fraction, you actually square the top and the bottom. So 1 squared is 1 over 2 squared is 4. Plus 4 times a half of 4 is 2. And let's see, 1/4 of negative 4, well, those 4s would cancel out. It's just going to be negative 1 plus 2 minus 2. So it ended up turning out to be an okay number here. Negative 1 plus 2 is positive 1, and positive 1 minus 2 is negative 1. You can cross cancel. I'm not sure what. Yeah. That's what I like to do, the cross cancel trick. Yeah, myself. So let's see. So if the vertex, actually, I've been consistently trying to write the vertex in red as our starting value, is going to be a half comma negative 1, right? So there's the vertex, but they wanted to find the max or min value, which we already said max, and so the max value is going to be the negative 1. So the highest that this graph ever gets, bless you, is negative 1. All right. So let's ooh, pretty. Actually, I'm such like a downer when it comes to fireworks shows. I'm like, my TV can show more colors than that with more accuracy in its pixels. Where I'm just like, meh, I don't know. They're okay, I guess. So let's see. The function shown represents the height in feet of a firework t seconds after it is launched. Okay. The firework explodes at its highest point. That's convenient. So the question is, when does the firework explode? So this is going to be a t value. And at what height does the firework explode? That's going to be an h value. The height Actually, that's going to be tricky because I'm already using h for the x coordinate of my vertex. Wow, that's really weird. So here's the function over here. H equals negative 16t squared plus 128t. Could someone tell me what A, B, and C are? And, No, he was right with the negative 16, and the 128's the number in front there. Yeah, 0 will be the value of C, because it wasn't there. So, if I want to find... Well, here, hold up, just a minute. So the point that they're describing is the maximum. They said, right, it explodes at its highest point. So it's going to be exploding at the vertex. So I'm trying to find the vertex, so that means I'm going to use my negative b over 2a. So h is going to be equal to the opposite of 128 over 2 times negative 16. So that's going to be negative 128 divided by negative 32. Is that equal to 4? Let me, I think so. 128, it feels like, yeah, it's 4. So I get h equals 4 for the vertex, but what does the x-axis represent? It represents time, right? And the y-axis represents the height. Okay, so this is for when does the firework explode? It is t seconds afterwards. So this is 4 seconds after it is launched, it explodes. All right, that's what it represents. The weird part is that my x coordinate of the vertex is h, but the y-axis is h. So that is somewhat of a flip-flop in understanding there. So we got to be careful. So it explodes after 4 seconds. How high was it? Ooh, well, that's going to be a question for K to solve. And I can find that by plugging in 4 into the equation. So the height h this time, is going to equal negative 16 times 4 squared plus 128. Oh, slow down. Let us catch up, right? Sipping my coffee here this morning. So let's figure this out. 4 squared is 16 plus 128 times 4. I feel like I should know that. 512. Negative 16 times 16 is, yeah, the negative 256 plus 512, and that combines to be positive 256 as the K value, right? Poor naming of letter conventions here. So this is vertex H, this is vertex K. Yeah, craziness. So it explodes how high? $256. What was the unit measured in? In feet. 256 feet high. Hooray! Ooh, is what we say when parabolas get solved for their vertex. Ah, that's wonderful. Thanks for watching, Internet friends. Bye-bye.